谢啊！今天真是非常高兴有机会回来台湾跟大家沟通。If I were to focus on one AI technology today that I think is the most important technology to pay attention to, I think it would be AI agents. And I hope to share with you what I'm seeing in the technology landscape and why I think this is important. You may have heard me say before that I think AI is the new electricity. It's a general purpose technology with a lot of applications. And so a lot of work that lies ahead of us in Taiwan and around the world is to find the applications to which we can apply this wonderful new technology. There is a lot of hype and excitement about AI. And so people often ask me, where are the biggest opportunities? This is what I think of as the AI stack. At the lowest level is the semiconductor layer, often made here in Taiwan. And then on top of that is the cloud layer. And on top of that are the foundation models. Whenever there's a new wave of technology, like we see with AI, a lot of the media interest and buzz is on these technology layers. And that's fine, there's nothing wrong with that. But almost by definition, for the technology layers to work out, to succeed, there's another layer that had better do even better, which is the application layer, because we need the applications to generate even more revenue to be able to afford to pay the technology layers that lie underneath. So even though a lot of the media buzz and the excitement is on the foundation models and the other layers, the technology layers, I think almost by definition, the application layer had better do even better. And for a lot of businesses in Taiwan, the best opportunities, I think, will be to focus on building applications that are now possible. And in terms of applications, just for fun, I did this actually earlier this morning. See this one? No.
In the future with AI agents on our minds, creating worlds of wonder in these innovative times. From the streets of Taipei to the brightest shining screens, we're coding new realities, fulfilling all our dreams. Entrepreneurship alive in every heart and soul. Startups rising fast, they're breaking every mold. Taiwan's tech giants leading, pushing every way. In this digital revolution, we're lighting up the day. Celebrating AI, we're under Taiwan's sunny skies of creativity, unfolding and ambition on the rise. From the smallest startup building to the largest corporate floor, unleashing innovation, opening every door.
And I think one thing that I think is underappreciated, I think we talk a lot about how AI makes us more productive. That's true, we'll talk more about that. I actually find that AI makes my life more fun too, and maybe that's important as well. So I think the topic of this meeting is AI agentic workflows. I want to share with you why I think this is such an important technology trend. It turns out that the way most of us use large language models today, like ChatGPT or Gemini or Claude Anthropic, is by going to it and typing a prompt and asking it to write a response for us. And that's a little bit like going to a human, or in this case, going to an AI and asking it to write an essay by typing it out from the first word to the last word all in one go without ever using backspace. And as a person, I don't do my best writing like this, but despite the difficulty of being forced to just write one word at a time from start to finish, AI does remarkably well. But it turns out that with an agentic workflow, we can get AI to do much better. So for example, you may ask an AI to first write an essay outline, and then ask it to think, do you need to do any web research? If so, let's go online and fetch some web pages and put that into the input context for the AI model, and then write a first draft. And have it read this first draft and see if it has ideas for improving it, and so on. And it turns out this workflow looks more like this, where you have it do some thinking, then revise it, and then do some more thinking, and you go around this loop a few times, maybe a lot of times, and this results in a much better work output. Earlier this year, my team collected some data from an AI benchmark, which is a coding benchmark, where we test how good is AI at writing code to solve little coding puzzles. So it turns out GPT 3.5 on this evaluation metric, PassAK, they had 48% accurate, succeeded 48% of the time. GPT-4 is much better, 67% success rate. So GPT-4 is much better than GPT 3.5, no surprise. But it turns out the improvement from GPT 3.5 to GPT-4 is much smaller than the improvement from GPT 3.5 to using an iterative agentic workflow. And GPT-4 with an iterative agentic workflow also does even better. So the improvement from one generation of model to the next is actually smaller than the improvement from one generation model to just wrapping it in the agentic workflow. So normally I don't get that much more technical in presentations like this, but given that this meeting is all about AI agents, I thought I'd take a few slides to just explain and demystify a little bit more exactly how these AI agents work. So it turns out that as developers, we have multiple design patterns for how we program agents. One of the most basic but really important design patterns is a reflection design pattern. I'm just going to talk about this to demystify how this actually works, right? So if I want to use AI to write code, I might write a prompt to say, please write code for a given task, and the AI might write some code for me. And it turns out that you can then ask the AI, here's some code, and just show it the code that it just wrote, and say, read this code and critique it and come up with ways to improve it. This is called a reflection workflow. We ask the AI to look at what it wrote and just see if it can do better. And sometimes the AI will find some problems. And if your large language model finds some problems, you can tell it, great, please take the thing you just found and improve the code, and rewrite the code, and so on. And if you do this a few times, sometimes you end up with a better work output. This isn't magic. It doesn't find every problem. It doesn't make everything work 100% of the time, but it does work better than not having a reflection workflow. And it turns out that when you think about building agentic AI systems, rather than prompting a large language model to critique its own output, another common design pattern is a multi-agent output, where we may prompt a LLM to sometimes say, your job is to write code. Sometimes we can prompt the same LLM to say, your job is to critique the first model's output. And so this is maybe a foreshadowing to when you can prompt a large language model to create two AI agents that have a conversation between them, and this results in a much better work output. I find that when people actually see how this works in detail, it often seems much less mysterious than it actually is. In terms of agentic AI design patterns, another thing that more and more AI models are able to do is what we call tool-use or function calling, where the AI system can call a web search tool, or call a code execution tool, or call an API to issue a refund, or call an API to fetch some data from someone's calendar, or call an API to do a web to click on a web page. And AI agents able to call other functions to take actions is expanding what AI models can do. Another key capability for agentic workflows is planning, in which if you give an AI system a complex instruction like, please generate an image where a girl is reading a book, her pose is the same as a boy, describe the image, then AI can plan out the sequence of actions it needs to take, like figure out the pose, generate a picture of a girl, do text-to-speech, or do image-to-text, do text-to-speech, but AI is able to not just take one action, but plan out complex sequence of actions in order to carry out complex tasks. And then lastly, multi-agent collaboration. It turns out that more and more teams are implementing not one single agent, but implementing a group of multiple AI agents. One of my friends, Joe Maurer, often talks about taking a manager's mindset, where if you're a manager and you think you might hire 3 or 4 people to do a task, like write code or generate marketing design, then think about implementing 3 or 4 AI agents and have them collaborate. And this seems to be an effective design pattern for getting work done with AI systems. So with these design patterns, AI builders have a rich portfolio of tools to build much richer AI workloads than was ever possible before. And to update the picture of the AI stack, this is the picture I showed just now. We're seeing that there's an emerging orchestration layer that is helping to coordinate the foundation models. And what has happened in the last year is the orchestration layer. Orchestration means software to coordinate a lot of function calls, a lot of usage of the foundation models. Is the orchestration layer is becoming increasingly agentic. Some of you may have heard of LangChain, this very popular orchestration layer. Started, I think, something like 2 years ago, but LangChain is evolving to LangGraph, and many of these orchestration layers are becoming more and more agentic. And this will, too, make it easier to build applications, but this also does not change what I said earlier, that I think the most valuable part of the stack, almost by definition, had better be the application layer. One of the things that my team, Deep Learning.ai, does is we're fortunate to work with, I think, pretty much all the leading generative AI companies in the world to create AI courses to share online, often for free. And so I find that as these tools get better, our ability to work with the tool builders to teach courses, to teach people mainly to build AI applications, I think that hopefully enables more developers to take advantage of these tools. So building on the AI agentic technology trend, AI is such a broad field. There's so much going on, right? There's one technology I think is worth paying attention on. I do think is agentic AI, but there's more than one trend going on in AI. So what I thought I'd do is just take one slide to share with you 5 more AI trends I think are maybe 5 of the most important trends I could think of. The first one is the semiconductor one, which is that agentic workflows consume a lot of tokens, meaning they read a lot of text and output a lot of text because they go through this iterative workflow where they keep on reading and outputting. And what this means is agentic workflows will generate from faster, cheaper token generation. The text of the large language model reads or writes, we call it tokens. So when you see token, think of that as just text generation. And many startups are making new semiconductor chips for very fast, very efficient token generation. Previously, you might wonder, why should an AI model generate text faster than the human can read? If you use ChatGPT or Gemini or Claude, you don't need to generate text faster than human can read. But it turns out when the AI is talking to itself, my teams have built AI workloads that might take 20 minutes to complete because it's talking to itself for a long time. And we have faster token generation. You can cut down that 20 minutes to maybe 5 minutes, and it's actually very valuable. And so I see really exciting semiconductor work. Interestingly, I think SambaNova and Cerebras, I think they make the semiconductors in Taiwan. Interestingly, Grok does not. I'm not 100% sure, but it's kind of but I think that there's a lot of well, anyway, hopefully, I think it's actually an ecosystem that Taiwan is naturally, poised to participate very strongly in. And then another trend that will affect many businesses is Gen AI is making it possible to build AI prototypes very efficiently, and this is changing the corporate innovation process. So when we were mainly using supervised learning or predictive AI or deep learning, to build a system, we may collect data, train an AI model, then deploy a model, and this used to take 6 to 12 months or something. We built a lot of valuable AI systems with a process like this. Collect lots of data, train a model, deploy it, right? This works, nothing wrong with that, we should keep on doing this. But with prompting-based AI, we can, with a large language model, write a prompt, and then deploy it, and so you can often ship prototypes in 10 days that used to take me and my collaborators maybe 6 months to build. And this is really driving changes to the corporate innovation process, because if it's so cheap now to build and deploy a prototype, then instead of betting on one idea, maybe implement 20 ideas and see what sticks. And if 18 of them don't work, it's fine, throw them away. And so it turns out that writing software has many steps. Design the product, implement the AI, do the system integration, safety, guardrails, compliance. So there are a lot of steps. One step's gotten much faster. Some of the other steps can still take a long time. But I'm seeing this new processes go backwards in the corporate innovation process to change the way a lot of companies prioritize. I know we like to talk about failing fast, but the ability to fail fast in terms of AI prototyping is now really high. So it's just changing the way that companies innovate. I know that move fast and break things, this mantra, got a bad word, got a bad reputation. Maybe don't take a picture of this yet. I want to show one thing. But I think this got a bad reputation because it broke things. I think some people interpret this to mean we should not move fast, but I don't agree with that. I think what we should do is move fast and be responsible. And I think there are lots of ways for corporate innovation teams, startup teams to very quickly build prototypes, ship them or test them in a safe and responsible way and move very quickly. So actually, my team AI Fund works with a lot of large companies, and hopefully we can really use this to drive much more AI innovation. And then something that may or may not be obvious, but the text processing revolution is already here, right? We've seen, ChatGPT and so on. Something that may not be as obvious is the image processing revolution is coming as well, and this will create many new visual AI applications. So I think this will impact manufacturing, self-driving, a lot of security applications, a lot of, and I think that, and by image processing, I don't mean image generation, although that's nice too. I mean image analysis or image understanding what's in the picture. And this technology is not nearly as mature as text, as understanding text, but it's getting much better. And in fact, some of my teams actually built agentic visual AI workflows. So we built a visual agent, for example, to have agentic workflows to analyze images, and this will unlock a lot of new applications. I suspect some of you may have a lot of images or videos stored in blob storage in a cloud somewhere. I've done that because I didn't have ways to look at the images and get that much value from it. And I now see more businesses with the capability to analyze those images or videos. I think this will create new applications. One other trend that will affect a lot of developers is the gravity of data is decreasing. So in technology, there's this concept called data gravity, which reflects the observation that if I put my data in some cloud, it's unthinkable to transfer my data, to transfer a terabyte of data from one cloud to a different cloud for processing. You just don't want to ship a terabyte of data, from Google Cloud to Azure or AWS to somewhere else or whatever, right? But it turns out that with Gen AI, the compute workloads are so intensive that transmission costs are now small compared to the compute intensity. So back of the envelope calculations, to transmit a gigabyte of data from one cloud to another might cost 10 cents, US dollars, 10 cents. But to process a gigabyte of data, even using the cheaper models like GPT-4 Mini, one of the cheaper models, that may cost $30, $40. So the cost of transmission, 10 cents, is much smaller than the cost of processing. And what I'm seeing, therefore, is a lot more AI workloads are sending data packets all over the internet, where instead of everything on one cloud, you may base most of your data on one cloud, but it's fine if you send your data packets all over the internet for processing. So it's actually a very exciting trend. Creates a lot more opportunities for businesses and for startups as well. And then lastly, I think data engineering has always been an important part. I think that to get your organizations AI ready, data engineering, data infra, this is my last one on the slide, it has always been important. But what I'm seeing a lot of large corporates do is rethink data engineering, but particularly on the management of what we call unstructured data, and that means text, images, and maybe audio. Previously, most data engineering focused on structured data, the tables of numbers, because that's where we got the most value from a lot of AI. But as AI is now better able to understand text and images and audio, there's a lot more data engineering to get companies AI ready on the unstructured data aspects. And so I'm seeing a lot of very large scale, enterprise, like kind of corporate data re-engineering, because we now have capabilities to process these. So this is just, I thought, a selection of 5 trends I thought may be relevant to a lot of Taiwan businesses, but I think there's just a lot going on in Taiwan and around the world. And one thing that I spent a lot of time thinking about is corporate innovation. I'm excited about startups and AI entrepreneurship, and large businesses already have scale, and helping large businesses adopt AI will be an important part of how we drive economic growth in Taiwan and elsewhere. So this is a chart from a research paper by some friends at UPenn and their collaborators at OpenAI that shows on the x-axis salary, and the y-axis is how exposed different jobs are to AI automation. And the interesting thing about this chart is the higher salary jobs that are more exposed to this wave of AI automation. With the earlier generations of AI, it tended to be the lower wage, routine, repetitive work that was more amenable to AI automation, like factory automation or industrial automation. With this generation, it's more knowledge work that is exposed to AI automation. Oh, by the way, the curve does start to come down a little bit. So I think everyone in this room, I think your jobs are pretty safe. And there are also just a lot of opportunities to drive efficiencies in knowledge work. And so what AI Fund has been doing has been working with partners to innovate and build startups. So just quickly, share with you a process that we use that seems to work well that hopefully would be interesting to some of you as well, which is AI Fund. We've always talked to a lot of partners to explore different ideas in AI. And as an illustrative example, a few years ago, Mitsui Corporation came to me and said, hey, Andrew, you should have AI Fund use AI to look at global shipping, weather, ocean current data to optimize how ships sail to help them be more fuel efficient. So this became Bearing AI. But what we do is look at an idea and validate that there's a market there and it's technically feasible, and then recruit a CEO, founder in residence, to work with us to build a startup. In the case of this idea, we recruited Dylan Kyle, who is a repeat entrepreneur with one successful startup exit before, to be the CEO for this project. And then we will typically then work with the CEO for 3 months to build an initial technical prototype. And I'm sharing this because I hope to be doing more of this in Taiwan as well, right? And then if the company still looks promising after we build a technical prototype, we then invest $1 million into the startup, and it's off and running and continues to scale. So the outcome in this particular example was Dylan and us and Mitsui Corporation wound up building this company that today it runs on over 600 ships on the high seas right now, and for each ship averages about $500,000 of fuel savings per ship per year, as well as about 10% CO2 emission reductions. And what I find is that as an AI person, I don't have a right to play in maritime shipping. Like, what do I know about ships? And as often when we combine the expertise of, say, an AI team, like AI Fund, and deep domain expertise about industry sector, that then the ideas for new opportunities can be identified and built in a more promising way. And so my team AI Fund, we spent a lot of time thinking about how to help large corporates identify and execute on AI opportunities. I want to share with you just very briefly a recipe that seems to work well. I'll go through each of these bullets very quickly, right? But first is executive briefing on AI technology. I think is often useful for executives to learn at a business non-technical level just a little bit about how AI works to help spot opportunities. So the fastest growing course on Coursera last year was Generative AI for Everyone, a course by deeplearning.ai. But I think things like that help executives gain a non-technical business level understanding of AI. After that, we then, the teams can then brainstorm AI projects. And what we found is that every team we talk to has lots of ideas. And additionally, there's one way to brainstorm AI projects, and I share with you that we found particularly useful as well, which is something called the task-based analysis of jobs. So it turns out people often think about jobs being automated by AI, and for labor, employment, social reasons, I think that's a good conversation for governments and society to have. But from a business analysis point of view, I find it more useful to think of AI as automating tasks rather than jobs. So jobs comprise many different tasks, and what we do is look at the jobs done by, say, employees in the company, break it into the individual tasks and see which tasks are amenable to AI automation. This recipe was pioneered by a friend of mine, Eric Brynjolfsson from Stanford University. And maybe just to illustrate this with an example, customer service representatives, call centers, contact centers, are being highly disrupted by AI. And it turns out that customer service representatives do many different tasks, and some of those tasks are at high potential for AI automation, and some much less so. When we help corporate partners do this analysis, we're often surprised by the analysis. Often the biggest opportunities that a systematic analysis surfaces are not what we would have guessed. But what this does is helps point you in directions for things to potentially build. And I know that this may look like a recipe for cost savings, where I identify some tasks and automate that, but much more than you would guess. I would say more than half the time, when we go through this process, we'll find a task and make a task, say, 1,000 times cheaper. And instead of just taking the cost savings, which would be fine too, many businesses will say, oh, I can now do this task 1,000 times more. And so more than one would guess, this turns into a recipe for driving growth rather than just savings. And then lastly, after brainstorming, 10, 20, 30, 50 ideas, we often, I think then a systematic diligence on whether a project is feasible then leads into prioritization. And what I've seen is after doing diligence on whether a project is worthwhile, most businesses will face a build versus buy decision. And we often think, you know what, if you can buy the solution from someone, just go buy it. Like, why build it if you don't have to? Most of the time. But it turns out because AI technology is still so new, when we help most businesses think this through, a lot of the time what you need, no one has actually built this yet. And that then leads to a kind of build versus invest kind of decision. And what we find, in the case of Mitsui and the shipping example, it was interesting that because Mitsui did not want to have to pay for and hire and manage a team to do the ship optimization. Mitsui operates a lot of large ships on the seas, but did not want to have to be responsible for hiring an AI team, managing an AI team, and pay for the whole thing. So by splitting that into startup, which we did with them, that allowed Mitsui to get all the benefits of the fuel savings without needing to pay for it. And this type of process we found often helps build startups efficiently. And so this has been a nice way for companies to get all the benefits of the technology, get it built without needing to pay for and be wholly responsible for it. And I think long term, I think a lot of work on advice, strategy, and training. So we found that a lot of work to be done in AI around the world, and I'm actually eager to do more of that work in Taiwan. I have more to say about that in a second, but I think that there are a lot of opportunities for both startups as well as large businesses alike in Taiwan. And then before I wrap up, I just want to share one observation on governance of AI. So when I speak with governments around the world, as well as boards of directors and C-level, a common question I'm asked is, how should we govern, either from a regulatory standpoint or from a corporate governance standpoint, AI? And I think it's important when we think of AI governance to distinguish between technology and applications. So for example, an electric motor is a technology. It's also a general purpose technology used for a lot of things. And it could be put in a blender, electric vehicle, dialysis machine, or in a guided bomb. Some things we want more of, some things maybe we want fewer of. And so technology refers to tools that can be applied in many ways. And applications are specific implementations that solve a particular customer need. AI models, like large language models, are also technologies, and they can be put in lots of different applications. And it turns out risks depend much more on the application than on the technology. So if you're building a blender, let's make sure the blender is safe. If you want an electric vehicle, let's make sure the electric vehicle is safe. But the standards for safety for blenders and electric vehicles are very different from each other. And if you ask an electric motor maker to make sure their motor will only ever be used in a safe way, it's impossible for them to do much, right? Like how can an electric motor maker influence how their motor will be used? And there's a lot like that for AI too. If someone puts AI in a medical device, I think we know what we want and don't want, maybe, in a medical device. Let's make sure that is safe. But the responsibility and the burden should be largely on the medical device maker, more so than on the AI model maker, who really doesn't have the power to control how it may be used later. And it's been interesting that over the last year and a half in the United States and in Europe, there were very intense lobbying efforts from some of the large tech companies sometimes that have trained large foundation models to pass burdens on open source or open weight models. I think the large companies that didn't want to compete with open source or open weights, fortunately would manage to defeat the worst of those regulations. But I think if they had succeeded in passing regulations to stifle the technology and block open source, most places would lose out. In fact, if not for open source, I think Taiwan would have much less access to cutting-edge generative AI technology. So I think it actually be clearly in Taiwan's interest, I think in almost everyone's interest around the world, to push back on anti-open source regulations. But I was actually really surprised by the intensity of the lobbying efforts. And I think so far, I think Taiwan has wisely not done that, and I hope Taiwan will continue down that path. All right, and then just one last slide. I think I was really happy to be back here in Taiwan. And I don't know if you know, we announced just a few days ago that AI Fund has opened up an office here in Taiwan, and so we'll be continuing to grow our investments in Taiwan. this is under the leadership of our new stand up, Joe, of a new general manager, Joe. Oh, by the way, for those of you that haven't met her, Jill is one of the, 100 million people is a lot of people, right? So, 100 million people, a lot of people. So it turns out that on this planet, there are very few people that have ever built a product that reached 100 million daily active users. And Jill is one of those very few people that has that unique accomplishment. So really privileged to have her work with us. And she joins, is Joe here? And she joins Joe, who's the head of our engineering office. Where are you, Joe? Joe, right. Yeah, Joe's the head of our deep learning AI team in Taiwan, and we're continuing to grow. And so Joe leads an elite team of engineers. We're continuing to grow that team as well. And so hopefully you see that, and I really want to thank the support of NDC and Taiwan here for making this possible, as well as for hosting us today, AWS as well. But I hope that you've heard me say many times I'm bullish on Taiwan, but I hope that my teams here will be able to partner with many of you to do more of the work that hopefully will help economic growth in Taiwan. So really excited to be back here. Really, thank you for having me back, and I look forward to really having AI Fund and Deep Learning.ai, Joe and all of our teams engage more of you within the coming years. Thank you.